linear functions. A linear function, f of x equals mx plus b. Same old linear function you've been dealing with since 7th grade. Got a slope, you got a y-intercept. Is changing about the rules of being a linear function. To be a linear function, you have the highest exponent is a 1 on your variable, on your dependent variable. And we'll, as we progress through chapter 4, we talk about linear functions for the first couple of sections, and then we move to quadratic functions, which you've done a lot with in Algebra 1 and Algebra 2. We did quite a bit with quadratics, so we'll revisit those in the last section that we'll cover in chapter 4. So a couple of sections about linear things, and then we'll go to the quadratics after that. So linear functions, slope, y-intercept. We'll start with the easy thing, function value. So let's say we had the function f of x is equal to 3x minus 7, and they want us to find f of negative 2. What does that mean? For what? X. F of negative 2 means plug negative 2 in for x. So that'd be negative 6 minus 7, which is negative 13. So f of negative 2 is negative 13. What is f of 2 equals negative 13? What's another way to think about that? That's right. So it's a different way of writing an ordered pair. These two things mean the same thing. That's an ordered pair. Here's x, here's y. That's an ordered pair. Here's x, here's y. No difference in those things other than the notation. This is function notation. That's ordered pair coordinates notation. All right. So it's no different in what you're doing. So function value, whatever's in the parentheses, plug it in for x and simplify best you can. That's all you got to do there. All right. Very easy thing. Moving on. Let's get another function. G of x is 2/3 x plus 5. And the instructions are find the intercepts. What kind of intercepts can we have? We could have y-intercepts. We could have x-intercepts. Both of those things. You got to find both of those. Because it's a linear function, the y-intercept's super easy to find, right? What's the y-intercept? 0, 5. Because it's linear, we automatically know that. How do we find the x-intercept? Put 0 in for y. Where's the y? There's not a y in my equation. Replace g of x. G of x is the same thing as y, so we set that problem equal to 0 and solve. Go through the steps. Solving that. Negative 5 is equal to 2/3 x. And multiply by the reciprocal. Negative 15 over 2. So the ordered pair for that would be negative 15 over 2, 0. And there we have our intercepts out of that. Nothing you didn't do in 7th and 8th grade, as far as that goes. Function notation you may not have done down there. I'm not sure. Depending on, I know they do that now, but you guys, when you were in 7th and 8th grade, may not have been the case, depending on how things were going there. Exceptional things that happen with linear functions. There's a linear function. H of x is equal to 8. Let's think about what we know about that equation. Y-intercept 0, 8. Okay, good. So y-intercept 0, 8. Is there an x-intercept? No, there's not. Does this one have a slope? Slope is 0. So it does have a slope. It just happens to be 0. Because what's the line of the graph look like? Straight. Well, they're all straight lines. They're linear. Horizontal line. That's the correct word. Straight doesn't tell you anything. Just tells you it's not curved. So horizontal line has a slope of 0. So y equals 8 or h of x equals 8 is a function, and it has those properties. We know those things. What's the domain? That's chapter 3 stuff. We still got to do that. Negative infinity to positive infinity. Is that the case for every linear function? What are the things that change the domain? What are the red flags for changing the domain? Square root in the problem, x in the denominator. If it's a linear function, do you have square roots in it? No. If it's a linear function, is x in the denominator? No. Those red flags aren't showing up. So every linear function has that domain from negative infinity to positive infinity, or all real numbers. That's what every linear function will have, that same domain. The only thing that can change that is the context of a problem, like maybe if it's a word problem, something like that. You might know, oh, I can't go below 0 because we can't have a negative if the linear function was about production of a certain tool or something like that. You're not going to have a negative hours or something like that. So context in word problems could change that domain, but that's a different. That's different for every case. So sometimes it doesn't change it. All right, let's look at something we've already talked about: average rate of change. An average rate of change is also the slope. Another name for that. We know the slope formula: y2 minus y1, x2 minus x1. Now that you might see it written change in y over change in x, f of b minus f of a over b minus a. That's another way. This is the way your textbook tends to write it. We know because we're smart, but it's just that. That's all it is. Okay. Now, if it's linear, then the slope is going to be the same between all the ordered pairs in there. So if you pick 2 ordered pairs, 2 that are real close together, the slope is going to be the same as if you pick one down here and one up here. The slope, if it's a linear function, that's what's happening out of that. So when we talk about the average rate of change, it doesn't matter what 2 ordered pairs we pick if the ordered pairs came from a linear function. What we want to do is, example B, write the linear model for the given data. Okay, so let's get some data. T-chart, X and Y's. Let's say we had 20, 50, 40, 45, 50, 42.5, 60, 40, 70, 37.5. I left one out. I skipped it. 30, 47.5. Stick that in there somewhere. It doesn't necessarily have to be in order. Okay. Now, so we got some data. We got x values. We got y values. They tell us to write the linear model. As we progress through this chapter, they're going to give you data and not tell you if it's linear or quadratic. You're going to have to decide one way or another. Here, they're telling us it's linear, so we know we're going to need to find what 2 things in order to write a linear equation or linear model. What 2 things do you have to write a linear equation? You got to have a slope and y-intercept. Those were the two things we got to have, okay? Well, the data doesn't give us a y-intercept. If it gave us a y-intercept, what would be the x value? 0. So look for that. If you got a 0 and a number, then you got to think, oh, that's got to be the y-intercept because the data has it right on there. Okay, so they're telling us to write a linear model, so we need to find a slope, and then we're going to find that y-intercept. So let's find the slope. I'm going to use, just for sake of example, I'm going to use this ordered pair and this ordered pair to find my slope. Should get us a slope that is very close to the same, no matter which pair we do. But just for example purposes, I'm going to do that. On the quiz, I will tell you which two ordered pairs to use to write the equation. That way, I don't have 28 different or 23 different equations to grade or come up with out of that. So I'll tell you which two to use on the quiz as far as that goes. Now, so let's find a slope. Do 50 minus 45 over 20 minus 40. Yeah, I didn't do that in the right order, right? That's okay. 5 over negative 20, which is negative 1/4. So we get a slope of negative 1/4. And, we know that should be a slope-intercept form equation. So we have some of that stuff. We got the slope. So negative 1/4 x plus b y. And then we want to find the y-intercept out of that. So how can I do that? Plug in x and a y. So that b is the only variable that's left. So I'm going to pick one of these two ordered pairs that I used to find my slope, and I'm going to plug that in for x and y. 20 and 50 looks like a good one. 50 for y, 20 for x. So that's negative 5. Add 5. B is 55. So our y-intercept is at 55. So the linear model, f of x, or if this is in the context of some word problem, it might be talking about price or something like that, or cost, and you might see c of x or p of x or something like that. That part really is not super important yet. There we have a linear model. We can plug in one of these x values here and see how it did. If we plug in 60, negative 1/4 plus 60 is, or times 60, negative 0.25 times 60 plus 55. See how close it gets? Right on the money. Gets the right y value. You check some of the others, make sure it's a good model for that. If it's a linear function, you should, and this data is linear, you should be able to plug those x values into your function and get reasonably close to those. I say reasonably close because sometimes the data is not perfect. It's linear in nature. It's real close to a straight line, but it's not perfect out of that. So just should be within reason. A lot of section 1, it's right on it. When we get into section 2, it's more of a real world situation things. And in the real world, things don't work out perfectly all the time. We tend to make them do that in a math classroom, but it doesn't always work that way. Okay, so what two things again do we have to write the linear model? Slope and a y-intercept. The same way it was when we were writing equations of lines in 8th grade and 9th grade, and in Algebra 2 we did that some. We did that in the first section or first chapter when we were writing the secant lines and all that fun stuff. Same stuff, just dealing with data sets this time instead of another function out of that. All right, so the next thing we want to do is put this in the context of a word problem. This is kind of small probably for you to read. This is in your book. It's page 282. It's example 4. That's where I'm borrowed this from. And so in the context of a word problem, book value is the value of an asset that a company uses to create its balance sheet. Some companies depreciate their assets using straight line depreciation, so that the value of the asset declines by a fixed amount each year. The amount of the decline depends on the useful life that the company places on whatever asset that is. So if your company has cars that they give their salespeople, and they may depreciate those over a straight line depreciation. So they pay $30,000 for the car, and then they depreciate it, by a certain, $3,000 each year or something like that. They have a set amount that they just do that with all of their fleet of cars. So suppose the company purchased a fleet of new cars, and the sales force they paid $28,000 per car. They worked some deal with the dealership, $28,000 a car. The company chooses to depreciate each vehicle using straight line method over 7 years. So they're thinking, okay, if we depreciate that out over 7 years, we'll have gotten the life out of that car, and then we can go from there. So this means that each car will depreciate at this rate: 28,000 divided by 7, or $4,000 per year. Anytime we see per, what's that make us think the 4,000 is as far as a linear model goes? Slope. Okay, if you see the words per year, per something, you got to think, okay, that's probably the slope. Not necessarily always the slope, but it's most likely in the problem given there. So we want to write a linear function that expresses the book value V of each car as a function of its age X. So we want to write a linear model based on that. So that's just part A. We're going to start with that. Part A, write a linear function for that. So V of X, linear model. So we're going to have MX plus B. What do we know about the slope? It's 4,000. Just 4,000? Per year, true, but $4,000, true. But is it, are we, what's happening? What's happening when you depreciate something? It's losing, right? So that 4,000 needs to be negative. That's what I'm after there. So it's a negative 4,000 because it's depreciating, okay? An appreciation is an increase, and that might be if you invested in gold or silver or something like that, and your company's just hanging on to it. Or copper pennies. Those are pre-1982 pennies are worth more than a penny these days. So if you get some of those, keep them. Worth more than a penny. So slope here. What about the y-intercept? Why 28,000? That's right. That's how much it was at year what? Year 0. As soon as we bought the car, it was 28,000. So this has to be starting at $28,000 out of that, because at year 0 that's going to be the case. So we have V of X is equal to negative 4,000 X plus 28,000. I feel weird putting commas in my numbers. All right. B part says to graph that linear function. So if I'm going to graph a function, I got a graphing calculator, right? Let's worry about graphing it on that. So negative 4,000 X plus 28. 1, 2, 3. All right. Now, when I graph this, is it going to fit on my 10 by 10 window? No. So that means I'm going to have to change the size of my graph to fit that. All right. So if I hit graph, we verify. I got something else in there somewhere. All right. Now, let's change the window. So hit window, And then our X-min and our X-max, we're not going to get, we can leave those the same. That'd be fine. On our Y, min and max, we need to change those, right? Because what's our y-intercept? 28,000. So that's a good ways up there, right? So we could leave our min the same if we wanted to, but our max definitely needs to change into something really large. Let's say let's go to 30,000, just a little above that, so we're not scraping the ceiling there. And then our scale, we could change that if we wanted to. If we were going to graph this on paper, we would definitely change the scale, go by like thousands or something like that. That would be a good move. Since we're doing it with technology, that scale really is not going to affect us too much. We're going to get that picture. We knew that it should look like that anyway because the line has what kind of slope? Negative slope, and we know negative slope should do that. Right? That makes sense that it looks like that. So we graph that. We know what it looks like when we graph it. Wonderful. Great. Whoopee. Let's go to the next part. So B part, we graph. C part. What's the book value of each car after 3 years? So how do we find that? Plug in 3 for the number of years. So that'd be negative 4,000 plus 3 plus 28, or 28,000. So 3 times negative 4,000 is negative 12,000 plus 28,000. How much? $16,000. So after 3 years, those cars are worth $16,000 a piece, according to for our accounting purposes out of that. So nice, easy thing. Go to D part. Interpret the slope. Let's talk about that. What does the negative 4,000 tell us is happening? Okay, yeah. So every single year, the worth of the car is going down by $4,000. That's what interpreting that slope would mean. Because it's a negative slope, we know we're reducing the value of the vehicle. If it were a positive slope, we would be increasing the value of something. So when it talks about interpreting the slope, just explain what it means. Does it mean the value is going down out of that? Use a sentence out of that. Okay. Now, so when the question is to interpret the slope, then definitely use a sentence to do that. Okay, so interpret slope. The value of car decreases. $4,000 each. Okay. E part of this particular problem. When will the book value of each car be $8,000? How do you know that? Okay, so mathematically, how do you come up with that? That's logically, that's correct and works wonderfully. So we have V of X is equal to negative 4,000. We don't know that it's 5, though. We know that that's going to be the answer after we solve it. V of X is actually, we're looking for the value of the car to be $8,000. So change V of X to 8,000. and solve that. That's mathematically, because what if they said when will the value of the car be, $3,750? That's an odd value, but maybe that's the mark that we've decided we need to sell that car at once the value gets to that. So they might not give you an easy number like 8,000 out of that. So logically, doesn't always get you there as easily. And I'm not against solving it in your head. That's absolutely wonderful. But what if they give you a weird number so that you've got to actually do it? So divide by -4 grand. And there we have the 5, and that's 5 years. So be careful. We're in the context of a word problem. We need to make sure that we're using units and things to say our answers out of that. That's fairly important. Okay. All right. Next one. Let's do example F, I guess, or this is actually on page 283, and I didn't get a picture of this one. I meant to. Supply and demand. All right, so look at page 283, example 5. There, they give us a supply and demand functions that we want to use. That they have figured out that the supply function is 60p minus 900, and the demand function is negative 15p plus 2850. Okay. All right. So supply and demand. Let's read the context of the problem so we know what we're talking about. Cellular telephones. That sounds fun. Nobody says that anymore. That's what everybody called it when I was in high school and everybody started getting one. It was funny. My oldest brother was in high school and one of his friends had a bag phone. Literally, it was no kidding. Don't worry about that. This was a bag phone, and it weighed about as much as this does. No kidding. And it was like $10 a minute. It was unreal expensive. And you had no service pretty much anywhere. So I didn't understand why anybody had one of those other than stats. But bag phones, they were the thing. And my oldest brother was in high school. When I got in high school, cell phones came along, and they were wonderful. And, it's more like this. So, you'd be talking on your phone and be like this, but it weighed about, a pound and a half, to forget. And now you guys tote around a supercomputer in your pocket and do, rocket science and all kinds of stuff. And it is. Yeah, do what? It's going to be out of nowhere in the middle of the video. Yeah. All right, so cellular telephones, they've got this function for supply and demand of those things at a given price. P stands for price. The supply function uses the same variable as the demand function. Makes sense, right? And what they want to find here is the first part. Let's find the equilibrium price. If something is in equilibrium, what does that mean? They're equal to each other, absolutely. So what price will the supply meet the demand? That's what we're finding. So when is S of P equal to demand? Supply equal to demand. So set those equations equal to each other. So 60p minus 900 is equal to negative 15p plus 2850. Solve for the price. And 15p and 900. 75p equals 2850 plus 900 would be 3750, right? And then divide by 75. Everybody knows there's 75 times tables. 3. Yeah. Not quite. 37.50 divided by 75. $50. $50 is our equilibrium price. That's what they say. Okay, we charge $50. We're gonna get supply and demand to match up. If we charge $50 out of that. Okay, so that's a good thing when your supply meets the demand. Right. So what happens to what price creates a greater supply than there is demand? If you're a company, it's not a good thing. Part 2. What price or prices create a greater supply than demand? How's that work? Under $50? Mathematically, what are you setting up to decide if supply is greater than demand? Yeah. You're setting up an inequality with the greater than in it. And then we know that we've already solved this, as an equation. We've done all that work and we knew that P should be greater than $50. If we charge more than $50, then we're going to have phones sitting on the shelf that people aren't buying. Imagine a $50 phone. Unheard of. It's unreal. $900 phones is what we're paying for now. But if we charge less than $50, what's going to be happening? Yeah, we're not going to be able to. There's going to be people wanting that phone and they can't get it. So what happens when your demand is higher than your supply? Price goes up. That's when you can start selling your phone that you already own for 3 times what it normally costs. Out of that, I know the Supreme brand stuff, clothing that drops once a week thing. That's the whole idea, is supply and demand. They make sure that the supply is very low, and then they sell out. And then those guys get on eBay and they sell it for 14 times what it cost originally. For a T-shirt, it only costs $15. That Stoltz could make you a copy of, or Root could make you an exact same T-shirt, probably better, for about $3. They're charging $80-$90 for it. All right, so supply and demand, those principles about equilibrium price, know what that means, set them equal to each other, and then pay attention to what they're asking for. They may ask it in a different order sometimes, and that's where a lot of times you get mistakes happening, that you'll do the correct math wise, but you won't set up the correct problem. So that tends to happen sometimes in this section. So got a little bit of time to work today. So page 284, let's do 1 through 50 is a good, you can do the odd ones if you want to out of that. So a lot of different questioning in this section as far as each, when you get into the ones that have several parts, subparts in a problem, there's a lot of different questioning. So make sure that you're understanding what they're asking for as you do that, okay?